So I will now go and try and do a new script. Okay, I'm gonna take some things, so it's a bit easier. I'm just gonna take this one. Okay. Okay, so I'm gonna save this so this can be I'll put it on the GitHub page so you can like uh, um so you can have a look at this script online. Okay, so moving on to a direction tuning curve. So this is just the basic for any BonVision stimulus, you need to use a create window, which is just kickstarting the OpenGL shader package, and creates a window. You define you can define whether you want a full screen or different aspects of it. I think we've covered this in a previous video. Then you have a BonVision resources and texture resources. We actually don't need texture resources in this case, but yeah, delete that as well. Okay, so now we just have render frame. This is how we start any of the stimulus. As I just mentioned, we use orthographic view, and then we say subject, we add a draw stimulus node, and then from here we have sphere mapping. So let's go here and cover -90 to -90, and then okay. And after sphere mapping, we have a view window just to look at, let's say 15 millimeters by 20. All right, we have something kind of close to the animal. This should cover a pretty decent area. So, and now I take draw stimulus and I put a draw grating node. So in this case, I'm going to be covering how you change how you create a direction tuning curve stimulus. So just need to define this. So this is going to be in degrees now, draw grating. So I'll have it as just have a large one, 90 degrees, 0, location 0, 0. Not sure, I'm just going to say 0.2. City phase radius 5. Spatial frequency, I'm going to make that 1. Temporal frequency, this is whether it's moving or not. So I'll have it as 3. Okay, let's just draw that. Okay, so you can see now there's a full screen, almost full screen stimulus. Now we can play around with the parameters. So this is just a grating that's being presented on the screen. You'll notice that the center here has, actually, I'm not sure you're gonna how well you see this on Zoom, so I'll make this a bit smaller. So you'll see here that the center has grating, the distance between the gratings is smaller, and at the edges it's wider, and that's because of this correction of the screens that happens automatically. Make this move slower. Okay, so just gonna make the aperture so we have a bit of make them a bit smaller. Okay, so now we have let's make this. So here's the stimulus. It's just a grating that's constantly drifting in one direction. And if you want a direction tuning curve, we want to be able to present the stimulus drifting in different directions in different instances of time. So what we want to change is the angle. So if I make this 30, you've rotated it, I've made it 90, you've done another rotation. All right, so the question is, how do we do this? How do we make a stimulus where a classic direction tuning curve in a classic visual neuroscience experiment would be that you have the stimulus on for a second or something, or half a second, and then off for a while. Then you have a new direction, a random direction usually, and then you have another direction and so on. And you can have multiple directions. So how do we generate that stimulus? So, okay, so we want to change the angle, and we want to, so the first thing is we want to present this for a second, and then we want it to turn off, and then turn on again. So let's just put take a timer, and the way we do that is we say take until, and then we put a timer. Just remember we need to use a shaders timer, and that's because that's related to the graphics card. So this, I'm just going to externalize this to say, well, let's just put it as going to have it on for 1 second. And then we want to have it off for a while. So the way I would do that is we can just have take until. And first, I'll just put it. Okay, one way. So I'll do it a slightly different way here. So I'll just copy the same thing and put it there. And now this draw gradient, I can just make the contrast 0. So that's just one way of doing it. So in this case, what we'd have is we have a grating at full contrast being presented for 1 second based on this timer, and then the grating with 0 contrast, so basically a blank screen presented for 1 second. And that's it. Waiting for a second, off for a second, and then it's there's no workflow end here. That's why it doesn't stop. But let's say we want to present this like if we want to have this keep going, so we just say we have a repeat count, and let's present it 3 times. Okay, so 1 off, 1, 2 off, 3 off. Okay, so that's done. So you're able to present a stimulus. This is how we present a sequence of stimuli. Okay, so now we want to say, okay, I want to present, let's kind of group this as one stimulus, right? And that does exactly the same thing. We've just not taken it out of here. Okay, so I go into this. So let me call this direction stimulus, direction stem. And I'm just going to say, okay, externalize angle. So when you externalize the property, it means it gets exposed here. So now when you press the stimulus, this group, you're able to see 90. And you can change this angle out here. So let's say 10 degrees. We've changed it there. Okay, so now we're just presenting 3 repeats of the same stimulus. So what we instead want to do is present, let's say, 3 different stimuli. So in that case, I'm going to take, I'll leave the repeat count in there, but I'll just say a concat here and just repeat the stimulus now. Right, so there's 3 versions of this. I'll put 0 here, let's say 90 here, and then to 70. And let's play this. Right, so you have 3 different directions, and it's repeating 3 times. And it's kind of getting to what we want to do. Make another one. So let's just. So this would have been 180. So this is an example of how you could do, for example, this stimulus, the direction tuning with just 4 directions. But to do this constantly, it's going to get quite messy quite quickly. So rather than presenting it each time, what we can do instead is we can make this, we can do it slightly differently. So I'm going to take these out. I'm going to instead make this a different kind of group called create observable. Now, right now, you've got to 0 degrees. So I'll take out this repeat. I should end it at the end. So now, yeah, I just presented it once and that was it. That's because we just have like the same stimulus that we had before. It's being presented once. Now, what is nice about create observable is right now it doesn't have any inputs going in, but let's say you have a float going in to this one, and now the float is, so it's this one, it's mapped to angle because that's the input that's taking. Let's look at it again. So to map it, let's see what happens. I'm gonna change. It hasn't done it, and that's because we need to map it. So we need to do input mapping. No. Oh, sorry. Sorry, I'm just gonna go back and group it as a normal group. So I need to externalize this and then put a float on. Right. This should do it. Now I'm gonna make this create observable again. Yeah. So I'm just gonna make this 90 now. Okay. So that did not show 90. And that is because it is not taking it in degrees. The angle is gone. We need to convert this into degrees to rad, right? So yeah, it's done it now. Okay, so so this was just one number, and it's actually, let's just I'm gonna ungroup no. So I'm gonna make it a regular group, and then I'm gonna group these ones so we don't have to see all of this. Right. Right. So this is doing exactly the same thing. I've just kind of moved it into the group rather. So if you look at the group, um, so if you look at the group now, it's just gone inside, but it's basically the same thing. Okay, so if you want, the good thing about create observable is if we have a sequence of numbers, it's going to present them one after the other. So now we have float of just 1/9. We just have 90. So instead of that, I'm going to take this and I'm going to repeat it 3 times. Let me, and then I'm going to say make them one string, right? And then I go 0, 90, 180, 270.
You could do a merge there instead of zip.
Right. Okay. So let's just run the stimulus now. Okay, so one of the things I mentioned was ideally we don't want to present them in a fixed sequence, and instead we want to be able to present them in a random order. And that can be done in Bonsai as well using a node called permute. And this, we can create a we need a random seed for it, so I'm just going to call that random. And let's put it into permutation. Is that how it? Is that permutation? Or? Andrew, is there something I'm doing wrong here? Okay, just going to save this temporarily. So this is going to check one. Just going to check one of my previous files. My tab. Okay. So back to this one. I guess we need to create a create random variable instead. Right, so it just needs to be this create random. Okay, I'm just going to save this now as direction 2. Okay, so if I run this now.
So I think you just need the merge sequence needs to close. So if you do take with 4 and then to list, it should
Sorry, Andrew, you need to take a take.
I'm not 100%, but I think so. You close the merge with all 4 values by adding a take with 4 as the property. So it closes the list with 4. And then because that's closed, you can now convert it to a list, which you can pass the permutation.
Right. So I don't usually use this. So the reason is I usually use a different strategy for this, and I'll show you that next. But that's why I'm not familiar with the fact that you need to take 4. Yeah. Okay, it makes sense now. But anyway, now we've got a list of 4 values, and we're able to permute them in a random order, and we're able to present them. Now, for now, we've just been presenting them once. Instead of once, we can present them more. And present them multiple times. So if you want to have multiple repeats of the same thing, let's just call it repeat count, and we present it, let's say, 3 times. I'm just gonna go in and make all this stimuli a little bit faster, so we don't wait as long. See them in 0.5, let's say, and then let's make it 0.25 off. Okay, so if I present this, it's faster now. There's 4 directions. Yeah, so that's all presented. Now, the reason I was a little bit confused before was because I don't usually use this strategy of taking 4 separate things and then merging them to do that. Instead, we actually have another node that we use very often, which is to just this node called parameter range. And that is something which creates a list of it just creates a sequence of numbers. So in this case, we want to create, let's say, 4 of them. We start at 0 and we go up to 270. So if I add a text visualizer just to show that. So let me just refresh that. So you can see this has created a list of 4 numbers. The same as what we did before was just listing the numbers, but this is just slightly easier. So now I'm just going to delete this bit here and instead add this where is it? I don't know why that got deleted. All right, so we're basically done the same thing, but now we've got it using this parameter range. So if instead we want to say, let's make it 8 directions, and we go from 0 to 330 in this case. So we go this way, we're going in 8 different directions, three repeats, and we've generated a direction tuning stimulus in this process. So yay. I think that basically kind of covers how you get a basic tuning curve. And I've taken you through going from starting with something like a draw grading stimulus, going all the way to generating a sequence of different directions and so on. So does anyone have any questions at this point regarding the direction tuning curve?
I have a question. So when you save, when you're like generating gratings like this, how hard is it then to save information about each grating that was presented?
Information about each grating that was
Yeah.
presented.
Like how challenging is that
Right.
to,
So at the moment, for example, like if we right, so you're talking about logging,
yeah, exactly.
right? So I think logging will have to be another session because there's a few different things to be done.
Okay.
But
Okay.
what I will say is that in general, so if you put a so you can put a sink here. That's how I would do it. So this is kind of, so when you put a sink object that basically passes the inputs through and passes, and it lets the pass, so it takes the inputs that are coming in and then it passes the inputs on the same way. So it doesn't actually interfere with the sequence. And in this sink, if you look at the source, you've got output, which is a double, which is basically this angle property of this stimulus. So we just need to write this angle property into a file.
Okay, I see. So you would just extract it and then put it into a CSV?
So the way we usually do it is we use these event loggers. So there's two types of loggers. So it's actually within the BonVision scripts as well. So there's log event and event logger. So logging, I guess. Yeah, so these are the three scripts here: event logger, frame event logger, and log event. So I would use a frame logger. You'd have to initiate a frame logger, and then you say log event at the end to save the event on that. I think this will have to be a unique live coding session. That's a good point. We should put it down on our list of topics to cover. I don't think I can really go into much detail at this moment about it.
Yeah,
That,
okay. Thank you.
okay. Right. So we've kind of covered this one. The next thing I would say is what I mentioned. Let's see how quick we can get there.